Well, let's take a look at the Gonset G-76. There's quite a bunch of nonsense that people have posted about this radio. Seems to be one good operational video on YouTube and not much else. So let's take a look at what it is, what it does, how it's built, and we'll just go over it. Basically what we've got here is an AM CW transceiver with good single sideband receive capabilities. It's a 6-band transceiver, 80 through 6 meters. It's got a VFO that works on 80 through 10, crystal controlled transmit on 6 meters. Basically what we've got is a 9-tube double conversion superhet receiver with IFs at about 2 megacycles and 262 KCs. It's got an IF selectivity of about 3 KC at 6 dB down and 14 KC at, I don't know, 50 or 60 dB down. Tailored for AM, but narrow enough for sideband. Certainly gives good fidelity. The stability is extremely good on sideband. You don't have to keep readjusting receiver. The stability is good. So far the VFO stability seems to be adequate for AM, but I haven't run it in the case for an hour or two and gotten it really warm to see what the VFO will do then. But initially the VFO seems to wander a little bit. So basically, let's take a look what we got here. Let's look at the schematic first. Pretty straightforward, but it's good. This is a 1960s technology, and if you're thinking that this is a repackaged G-76 Gonset mobile receiver from 1956 or 7, you would be wrong. It's much better than that. It's got a 6BZ6 RF amplifier. Half of a 6U8 is the first mixer. The other half is the RF oscillator. To mix it down to 2 megacycles, and then we've got a tunable RF oscillator going into the what they call the first converter, second mixer, whichever way you want to look at it. 6BE6, there's your first IF. 12BA6 IF amplifier. 12BA6 second IF amplifier. 12AL5 they're using as the detector, the AVC diode, and the automatic noise limiter, which is just a peak noise clipper, but seems to work pretty well. They're using half of a 12AU7 as the BFO, and the other half as the first audio amplifier for the receiver. Now the output from that first audio amplifier goes over here, and they use the RF driver tube for the modulator. They also use that as the audio output tube for the receiver, and it sounds good. It's got 2.5 watts of audio, which is probably almost double what a lot of smaller receivers have. And you can see that the output on the secondary of that transformer either gives 2 or 3 ohms for the speaker, or push-pull grid drive for the 6D Q6 modulators. So basically we've got a 9-tube receiver, we've got a 4-tube modulator, and we've got essentially a 4-tube transmitter if you count the VFO. 12BY7 crystal oscillator or VFO oscillator. Another 12BY7 as a buffer multiplier, and then the final tube, excuse me, the final tube is a 12 pardon me, is a 6DQ5. They call it a 676G, but that's a 6DQ5. So it's 6DQ6s, push-pull modulating, 6DQ5, about 90 watts input, 60 watts output. Let's see how it's laid out in the radio. Basically, you've got the transmitter in kind of an L shape here, with the modulator and the clamp tube here, oscillator and multiplier buffer driver tube there, and the final amplifier 6DQ5 is horizontal right there. The tank coil, let me turn this around. Now this is a transceiver, but most folks aren't very familiar with AM transceivers except maybe for CB rigs and some old 2-meter rigs. But this thing uses the tank coil here, the loading cap, the plate tuning cap, and the tank coil. This is used as the front end for the receiver, and of course it's the plate, the Pi network output for the final tube. So it's sharing that. Receiver and transmitter share this, and they also share part of the audio circuit. The modulation transformer, or pardon me, the audio driver transformer has that tap for the speaker and shares that 6CM6 audio driver tube. So it's sharing audio, sharing power supply, and sharing tank circuit. But all of the oscillators and frequency determining stuff for the receiver and the transmitter are completely separate. They have to be because of it being an AM transceiver and the way they work. Not a filter type rig, not Collins system. This is basically integrating receiver here, transmitter here, common audio, common tunable RF front end and output stages, and of course a common power supply. Let's look underneath and see how that's done. Okay, here it is, and at first it looks a little daunting, but it's really not very crammed. The wiring is extremely well done. It's not Klagen, it's not Collins, but it's very businesslike, very workmanlike, good construction, really. There are two push-to-talk relays necessary in here. They're swapping the meters back and forth between the receiver and transmitter. The B+, high and low B+, back and forth between receiver and transmitter. They're swapping the tank circuit between the front end of the receiver and the output of the transmitter. They're swapping audio around and switching the high and low B+. So there's two push-to-talk relays in there, 1 and 2, and then there's a single relay in the power supply, which is energized by the push-to-talk switch and connects the B+ to the transmitter. So unless the thing is key down, there's no high B+ in the radio itself, but there is 265 volts of low B+, and this power supply does not have any bleeder resistors on the low B+. So if you're going to work on this thing after you've turned off the power supply, you've either got to short out the low B+ or be very careful, because it can bite you. But anyway, let's take a look here. What do we got? Here's the transmitter. Over in this corner, that's the VFO tuning capacitor. Oscillator shared 12BY7, either controlled by crystals or as a VFO buffer tube, another 12BY7 driving the final tube, which is on the other side of the chassis. This is the grid tuning capacitor here, grid drive capacitor. So here we've got receiver RF amplifier coils, one for each band, because it's sharing the tank circuit from the transmitter and the receiver. Oscillator coils for all 6 bands, 80 through 6 meters for the tunable receiver. Here's the receiver proper itself. The RF amplifier tube is on the receiver is on the other side of the chassis, but mixer, IF, and a low-level audio all in there. That's pretty much it. It's pretty sanitary, not too confusing. One thing that I noticed on this thing is that the wiring for the mic jack is contrary to the practice of every other radio that I've ever looked at. Every radio that I've ever had, including ones that go back to the early 50s, all use the tip of the 1/4-inch plug as the push-to-talk, and the ring of the 1/4-inch mic jack for the mic. And this was reversed. And I just got in and changed the wiring because I use that same couple of microphones on half a dozen radios, and they all need to be common. And this was a bad design. I don't know why they did this, but if you slide your mic jack in there, if you get the mic on the tip, when it slides by the push-to-talk contacts on the ring, it can put voltage on your microphone and burn it out. You don't want that. So we eliminated that possibility by going to the conventional wiring. Okay, I've turned the transceiver around the other way so we can look at some other aspects of it. In the very earliest models of this G-76, didn't have these two tubes. One of these is a clamp tube for the final amplifier, and the other is a voltage regulator tube, I think, for the screen of the modulators, the final, I can't remember which, I think for the screen of the modulators. And so they added these two tubes, which don't exist in the very earliest versions of this. And down here, hidden in the bottom where you can barely see it, is that 6CM6, which is the audio driver for the modulator, and it's also the audio output tube for the receiver. So a little hard to see it, but it's down in there. What else? This socket right here is for the optional crystal calibrator, which I do not possess. And this tube right here is the 6BZ6. This is the RF amplifier, the front end of the receiver. And I think they put it there because it keeps the leads very short, because it's sharing this tank circuit. This acts as the front end of the receiver as well as the output circuit for the final amplifier. So it keeps the lead shorts and everything right together by putting this thing up on the top of the chassis. One thing I don't like about this is this little bracket is not as robust as one might like. Still, these things were used in mobile service and seem to hang together pretty well. The rest of it is pretty good. You know, this is a little flimsy. I don't like this too much either. I'm not using this rig mobile, but if I was, I would not be happy with that flying around, and I'd like at least a little support on the end of that tube. But the rest of it is good, and good quality components where, you know, ceramic switches where needed, and phenolic where they're not. All the voltage ratings for all the components seem to be good. And in terms of overhauling the thing, there are very few capacitors to change in here. Here's a paper cap. Here's a Black Beauty. That's a paper cap. Here's one electrolytic down here. And these couplets right here are part of the BFO. So there's no need to fool with those. You know, it's you don't have to worry about hi-fi capacitors in your BFO. It is what it is. This is kind of interesting. This control here operates. You can see this is a kind of a classic Centralab stackable pots with a switch on the back. So in sideband mode, one of these pots acts as an RF gain, and in AM mode the RF gain is fixed full on, and in AM mode the other pot is the volume control, and on the back is a little switch, so you pull this, push it on for automatic noise or noise limiter, peak clipper noise limiter, pull it out for normal operation. And you know, pretty straightforward. Here's that audio driver transformer with the voice coil speaker winding on it, and on the back, even though the power supply is a built-in speaker, they give you a jack in the back of the radio if you to have a speaker there, a mic jack and key jack. But be careful, because all of these are identical 1/4-inch jacks, and when I first went to stick my microphone in here, I stuck it in a damn speaker jack. So you gotta be careful. You gotta know where things are. S meter adjust, speaker output, mic gain, mic jack, power cord, crystal socket, 2 crystal sockets, one for HF and one for 6 meters, and crystal VFO selector, and key jack. Let's see, this is grid current metering jack here. When it's in you can meter the grid current when you're in the tune mode, but when you're transmitting, you can't monitor your grid current, so if you want to, you plug in an external meter there. There's the key jack, there's the antenna connector. Pretty straightforward. The other beauty of this thing is it isn't heavy. I'm an old man, and I'm lifting this thing with 3 fingers. I think this weighs 21 pounds, but it's not very big. I think it's 11 or 12 inches wide and 10 inches deep, and you know, 4 or 5 inches high. It's small. It's not heavy. They say it gets pretty hot. I haven't run it with the case on it yet for an extended period of time, but I will. Power supplies, I don't know, it's 32 pounds or something. It's a little hefty, but it's still not hard to do. If you can lift a small receiver, you can lift that thing. Let's talk about this power supply.